Okay, so we've configured our IP-enabled MOSCAD, another IP-enabled MOSCAD device. We've assigned it line 10. We'll just go through the port setup, fairly standard. We've given an IP address, tried to keep it as logical as possible. So let's begin. So previously we generated a network table to define the nodes in the system. So the nodes, as you know, are points in the network that are an interconnection point between two or more links. So that's what a node is. In this example, we've got a serial link. We've got Site 7 supporting serial links and an IP link. And we've got another node here, Site 14, supporting an IP link and a serial link. So let's introduce the IP conversion table. Click on System, and we'll go to IP Conversion Table Manager. Click on New, and we'll put our site ID 7, and the link ID is 10. And the IP address is 10.100.100.107. Right, and we'll put in the next one, which is 14, and that also is on line 10. And that is 10.100.100.114. Okay. Now the purpose of the IP conversion table is to map the site ID, the MDLC site ID, to an IP address. So pretty much we're saying that Site 7, if wants to communicate any IP-enabled MOSCAD in the system in this project that is on the same subnet as Site ID 7, will need to have this IP conversion table downloaded to it. So the IP conversion table only applies to IP-enabled MOSCADs in the system. Okay, needless to say, the IP conversion table is then downloaded to any IP-enabled MOSCAD RTUs in the system. Okay, so it's asking us to save the configuration, which is correct, which is yes. Click yes, and we'll give it a name, and we'll call it UNet1. Hopefully it'll take that, which it did. So UNet1, and we assign it to the IP enabled units in the network only, which in this instance is Site 14 and Site 7 are the only two IP enabled MOSCADs in the system. Very important that we don't download it to the other units. You can, but if there's no IP port enabled, it won't matter. It won't work because they're not. Yeah, it doesn't matter. So just only make a point of only downloading the IP conversion table to IP enabled MOSCADs used in the network. So we can then use this feature here, which I forgot to mention earlier, which is called Download All Sites. So from System, you go to select Download All Sites, you save the project, and the option to download all sites. So the IP conversion table is included with Site 1. We don't with Site 2. It's not. Site 3 it's not. It should be only with Site 7 and Site 14. Okay. Next we need to define Site 14 in our network table as well. So let's go back to our System and Network Manager. And we'll go back to New Net and we edit that one. And we enter, and we have to update Site 7. So we put in link ID 10. We add link ID 10. And in here we put enter 14. Now 14 supports line 10 and I think RS link 3. And we saved it. Oh, sorry, RS link 5, I beg your pardon. Let's just go back in here. Make that RS link 5. Save that. Close. Now that new net has been updated and it will be downloaded here. So the new net now contains Site 7, and Site 7 supports RS link 1, RS link 2 and line 10. Site ID 14, node 14, supports line 10 and RS link 5. And that's been associated with all the sites in the project. This means that each site on RS link 1 can talk to any site on RS link 3 via this IP link. Okay? and the same goes for any site on RS-Link 2. It will now be able to communicate to any device on RS-Link 5. As you can see, we've now added in our RS-Link 5 sites, and these RS-Link 5 sites will also require a network table to be downloaded to them. So the IP conversion table goes into the IP enabled MOSCADs, so that's site ID 7, site 14. The network table gets downloaded into all the sites in the network, meaning site 15 can now communicate with site 5 on RS-Link 1. So that means any site on RS-Link 5 can talk to any site on RS-Link 1 or RS-Link 2. Okay, and the site 7 and site 14 will exchange data on line 10, which is an IP link. Now it's important that when we configure an RTU in a system, when we configure RTUs in a system like this, that we don't include any unused links. So for example, in this computer, if plugin 2 was used as an RTU to RTU, let's say an RS-232 port, that is RTU to RTU, and it had used RS-Link 10, or let's say RS-Link 9 for example, used RS-Link 9, it's important that RS-Link 9, while RS-Link 9 is not being used in the network, ideally it shouldn't be configured in the RTU, and that goes the same. That goes for any of the RTUs in the system. So you might have site 11, and it might have a port configured for whatever medium or whatever media, and it might be an RTU to RTU. It might have RS-Link 15. Now it's important that we don't, or we try and not use, or try and not configure. We try not to leave these ports configured in the system, because it will slow things down in the event of a problem or something like that. So basically, what happens is if site 5 has data to send to site 12, and it can't get through on RS-Link 2, it will then attempt to make contact with site 12 on whatever ports it knows about, whatever ports have been configured. So ports that are in the network table, ports that are configured on the local RTU, it will work through each port sequentially until it gets a reply, and this happens 3 times. It's what we call retries. Now it's not ideal because it does take up system time. So if you can imagine, if this was a busy system or a radio system, you certainly don't want your RTUs continually trying to find the right link to the remote site or the peer site it's trying to talk to. So it's important that we don't include, or we don't configure links that aren't part of the network. So basically, site 5 with its RS-Link, just don't configure it. Take RS-Link 3 out of the network, out of the configuration. So just make that not used, or make it a local computer port. When you configure it as a local computer port, it doesn't appear in the network table and is not part of the network, and therefore it won't attempt to route any MDLC frames over that port or over that link ID. And the same goes with site 11 here. So again, we just make that a local computer port, therefore, or thereby taking any confusion. It doesn't add to any confusion in the system, doesn't confuse the system about where it sends data and things like that. That concludes our second video in introduction to MDLC networking. I've sort of covered the IP conversion table. I've covered the network table. If you need me to go over anything in more detail, or if you have any questions or queries, please feel free to drop me an email. As always, thank you for watching, and I will be producing more videos with a little bit more detail. As I've mentioned previously, any questions, queries regarding this project or regarding how MDLC works, any MOSCAD hardware service inquiries, please drop me an email. I'll do my best to respond in a prompt manner. And as always, thank you for watching.